We're going to now learn about tabular integration, otherwise called the DI method, and this method can save you a lot of time for certain integrals. This method is just a visual shortcut for performing repeated integration by parts when one function, let's highlight that in yellow, is a polynomial that differentiates to 0. For example, in these two integrals, that one function or polynomial would be x² or x³, while the other function can be integrated repeatedly. And that other function in these examples are e to the x and cosine x. So you have one function that integrates to 0, and then the other function you can just keep integrating. I have written down 4 steps that you can follow just to make this easier. Honestly though, after you do like 2 of these, you will completely understand how to do this without even having to refer back to the steps. We're going to go through these steps one by one as we go through our examples. In these examples, we are going to use tabular integration to evaluate the integral. Our first example is the integral of x² e to the x dx. Let's look back up here at the steps. Step 1 says that we're going to choose the function to differentiate and the function to integrate and set up the DI table. I already set this table up, so what we have to do is to figure out which function we're going to differentiate. We're going to differentiate the x² because that will differentiate to 0. So we're going to put x² right under our d, and then under the I, you're going to put the function that's left over, and that is e to the x. Now let's go back up to the top and look at step 2. What we need to do is differentiate down the d column until we get to 0, and then we're going to integrate down the I column the same number of times. Let me show you what this looks like. The derivative of x² is 2x. The derivative of 2x is 2. The derivative of 2 is 0. So you just take the derivatives until you get 0. And on the right-hand side, you're just going to integrate. With this problem, the integral is always just going to be e to the x. So we're going to put an e to the x for all of those. Now let's look at step 3 and also step 4. You can kind of combine these. We're going to assign alternating signs starting with the positive and then multiply diagonally. I'll show you what this looks like. You're going to take the x² and you're going to multiply it by the term that's down and to the right, and you're going to put a plus by that one, and then you're going to continue this pattern down and to the right, and you're going to alternate signs, so this guy gets a negative, and then down and to the right, and this one gets a positive. And then you don't have to worry about the 0 because that term's just going to be 0. Now in step 4, let's go back right up here. We're going to add these diagonal products and include our plus c. This integral is then our first product, x² e to the x, and that had a plus. And then our next product is going to be a minus. So we have a minus 2x e to the x. Hopefully you're getting the hang of this. And then our last product is a plus, and that is going to be plus 2 e to the x. And then our arbitrary constant c. Let's now factor out our common term. That is e to the x. So I'm actually going to write the polynomial first. So this is x² minus 2x plus 2 times e to the x plus our arbitrary constant. And there's our answer. If you were watching this entire lecture, you might want to go back to example 3 because we actually did this problem and it seemed much harder. Tabular integration is just great for saving time for these types of problems. Let's do one more tabular integration problem. You may want to pause the video and see if you can complete this on your own. We're going to start by choosing our function that we're going to differentiate, that's x³, and then the function that we're going to integrate is cosine x. Now let's go ahead and let's take the derivative. We have 3x², and then we have a 6x, and then we have a 6, and then a 0. And on the right, we're going to integrate. The integral of cosine is sine x. Integral of sine x is minus cosine x. The integral of minus cosine x is minus sine x. And then the integral of minus sine x is positive cosine x. Let's now write down what we're going to multiply, and let's put the signs with it. We'll multiply these two terms, and that gives us a plus. These two terms gives us a minus. These two terms give us a plus. And then the last terms are going to be minus. We can now write down our answer. Our first diagonal terms are x³ sine x. And then we have a minus 3x² times minus cosine x. And then we have a plus 6x times minus sine x. And then we have a minus 6 cosine x plus c. At this point, it's really good to go back and check your work and make sure you did all those plus and minus signs correctly. Now we need to write down our final answer. Let's combine terms. Let's go ahead and let's combine our sine terms. And this gives us x³ minus 6x times sine x. And then our cosine terms, we're going to have a 3x². Remember, we have two negatives there. And then minus 6, and that multiplies cosine x, and we have plus c. And there's our final answer. And that's it.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.